So, what are analytics? This is a huge topic. Three broad areas of analytics. The first is the past. This is where most of us have lived most of our lives. Data is historic. We do historic reporting. And that's always the first word I listen for when a customer asks me to do something. Could you create us a report on? I go, oops, stop. Why do you want a report? A report speaks to me of the past. By the way, reports are not bad things. The past, historic data is good stuff as well. But there are more sophisticated things that can be done today. So it's a good question. If you think you're asking for a report, stop and ask yourself, what actually am I trying to do? If I'm a security camera trying to catch someone that's walking across the parking lot, I want to take action now. So I don't want a report, I want action. But a report, the past is good. It's usually called descriptive analytics. It's describing what happened in the past. And diagnostic, tell me why it happened. Now, through IOT sensors, we can see things in real time. We can monitor our world around us in real time. What is that machine doing right now? Is it hot, cold, or whatever? And if I can see the past and I know what's happening now, I can predict the future. I can do predictive analytics. And this is the big thing everybody wants when I'm talking to them. It's, oh yeah, we want predictive analytics. I said, well, really? Let's discuss that. Let's discuss what you really need, what your business needs are. There is one beyond predictive analytics, which is called prescriptive analytics. And that's telling you what should you do about this prediction. Think of a game of chess. At any point in time, I've got a number of moves, and what I want to know is which one is most likely to lead me to the end game. So that's kind of the hierarchy. Each of them has their value, but they are different. The spectrum of analytics, and this is just, again, a sample of the sorts of things you can do, running from historic to the future. But yes, of course, you've got reports. You've got text mining, to dig into all of those tweets and texts that are going backwards and forwards to see who's saying what about my product or my service or my colleagues. There's a lot of well-known people using this sort of thing at the moment. Sentiment analysis, another thing a lot of people are using right now at the moment. But sentiment analysis, are my customers happy or not happy with my product? I can use these two things to find out. Credit scoring, risk analysis. Is this proposal a good or bad risk? Is this customer a good or bad risk? Should I accept them? All the way through to things like fraud detection, machine learning, and I'm going to come on to that in just a second, forecasting, and ultimately simulations. Can I simulate the future and help me understand where things are going? So there's a very wide range of things, and when people talk about analytics, you need to think of that. There's a lot of things you can do with analytics. But one of the things I promised to do in this session was talk briefly about machine learning, just as one example of analytics. It happens to be one of the more popular ones that everybody's interested in. So what is machine learning? Well, first of all, it's to teach a machine to recognize patterns in data without having to explicitly program it and say, hey, this is the pattern I'm asking you to look for. We're just saying, no, go ahead and look for stuff. There's two ways of doing that, which I'm going to cover. To give a couple of examples, which of the 10 categories an image falls into? This is zip codes. How does the post office detect a zip code? Handwritten zip code. Well, it takes an image of that zip code, it passes it to this machine learning algorithm, this computer that's been taught what a digit 0 looks like and a digit 1 looks like. And because the machine's been taught what those different digits look like, it can look at that zip code and say, oh, yeah, that's an 8, that's a 7, this is a 5. A different type of prediction. What's the probable diagnosis for a group of systems in the medical world? I give you a set of symptoms, and because the machine's been taught how to look for those kinds of patterns, it can say, yes, that is most likely to be XYZ condition. By the way, a word of caution. Predictive analytics is a wonderful concept, but the word prediction is dangerous. You cannot see the future. Neither computers nor human beings. It is not possible to literally predict the future. It's not a guarantee. It's a statistical probability. So what it's telling you is this is probably a digit 8 versus a digit 3. They tend to look rather similar in handwriting. And it can even give you a probability figure. You know, it's 9.8% probable that this is a 9 versus a 3 or something else. But it's never a guarantee. That's why the last election, the pundits got it wrong. Because under normal circumstances, all of the data predicted who would win. The problem was one of the candidates was unpredictable. And still is. Credit limits and so forth. So it's taking input and giving you an answer. And so how do we teach it what to recognize? Well, there are two broad approaches. The first is what's called supervised learning. And again, I'm giving you these terms because when you go out and talk with your data science department or whatever, hopefully you have one, if not, you need to start building one. Then these are some of the things that you can talk to them about. Supervised learning is where I help the machine to learn. And what I might do is I give it a series, thank you, a series of examples. Usually they talk about cats and dogs. I'll talk, well, fine, I'll talk about cats and dogs. I give it a series of pictures, maybe 1,000 pictures. Some are cats, some are dogs. And I don't tell it anything more than that other than, here's a picture, that's a cat. And the machine goes, okay. And then you give it another one. You say, that's a cat. And another one, this one's a dog. What the machine does, through some clever programming, is it starts to look for the differences. You told me that's a cat, you told me that's a dog. What's the difference between them? Well, this one has whiskers. That one doesn't have whiskers. Okay, so maybe whiskers is a determinant of whether it's a cat or a dog. And so on and so on. You give it lots of examples of things, and eventually it says, I got it. I understand how to take an image and determine is it a cat or a dog. Something that we do intuitively. But actually we were taught the same way. Our parents told us there's a cat, they usually say cat and doggy woggy, I don't know why. It's always strange to me why we teach children this arcane, difficult language. I mean, doggy woggy is harder than dog, but there we are. And then as soon as they've learned that, we tell them not to talk that way and to learn it properly. Anyway, that's getting to my soapbox. So we show it examples. And based on those examples, it eventually determines what are the differences between X and Y. What is the difference between a 3 and a 9? And it learns. And from then on, that's fine. Now I can just give it a random picture and it will tell me, yes, I'm 98% certain that's a cat or that's a dog. And there you are. You've got a machine that now knows how to help you make decisions. The other way is unsupervised. This is where you don't have a set of examples to give it. And what you do is you throw a whole bunch of data at it and say, look, I don't know what's in here. I just want you to go through the data and see if you can find some trends, some patterns. And I don't know what the patterns are. I just want you to go through the data and look for patterns. Now what comes out is a set of patterns or trends, but what the computer can't tell you is what those patterns or trends are. It just says there's a whole cluster of stuff here that all look the same, but I don't know what label to call it. I don't know whether to call it a cat or a dog, but I can tell you there's a whole, from all the pictures you gave me, there's a whole bunch of that look like this, and there's another whole bunch that look like that, and there's another bunch over here that looks like something else. And it's we human beings that say, oh yeah, that group over there, that's cats and that's dogs and that's giraffes. Apparently giraffes are big right now on the internet. And so I've discovered. So that's unsupervised learning. And these are important. I mean, these are two types of analytics you can ask your teams to develop. If you have examples that can be used to help teach the machine, then you can ask for supervised learning, and it will be able to help you determine, is this an X or a Y? Unsupervised learning you use when you simply want to take a whole bunch of data and say, just go through it and tell me if you can see patterns or trends in that data. Okay? So, some good candidates for machine learning. First of all, do you have sufficient reliable data? This is, by the way, true of analytics in general. Obviously, I've touched a nerve there.
Data quality.
Data quality. If you need sufficient, and not necessarily a lot, interestingly enough. Statistically, you can do some interesting things with relatively small amounts of data. But it has to be good data. It has to be good quality. It has to be representative of what you're looking for. Clearly, if you feed it a whole bunch of data from one source, imagine a city. I take a whole bunch of data from one city only. One side of the city, south of the river, and ask it to predict the effect across the entire city. Well, the input data was biased. It only had data from one half of the city, one community, one set of information. So it's got to be representative, it's got to be sufficient, and it's got to be good quality. You use machine learning where there isn't an obvious or easy to determine mathematical formula. If there is a mathematical formula, well, then you'd use it. You'd perhaps put it in a spreadsheet, 3 constituents for every car. Well, I can therefore predict how many cars we're likely to have if I know the population size. That's fairly straightforward. You use this when there isn't an easy formula to give you the answer. And where there is an underlying structure or pattern in the data. What happens is, if there isn't an underlying pattern or structure, the machine learning basically comes back and tells you there is no pattern or underlying structure. I can't find anything for you. Most things, oddly enough, there is a pattern. Even things that we think don't have a pattern, there is. If any of you have ever looked at chaos theory, it's wonderful stuff. Things like weather patterns we used to believe there wasn't a pattern. We used to believe that weather was chaotic. You can't predict it because there is no pattern. Well, we've learned over fairly recent years that there really is a pattern if you look hard enough and at the right things. So there's a whole bunch up here: fraud detection, social media, stock trades, help desk, it goes on and on and on. I will leave it at that point and see if you have any questions. Sir?
Evolving into home devices to more industrializing government. Have you thought about security and what's the best way to approach securing these sensors?
Sure. In fact, I did a big report on that for one of the government agencies. So security is a big issue, not just with industrial sensors and what's now known as the industrial Internet of Things, but also in our homes, in our general lives. Security is a big issue. So a couple of things I would say there, and I don't mean to sound trite or dismissive. One, we can't allow fear to stop us moving forward. The world is going to move forward. These sensors are coming, so we can't put our head in the sand and say, well, we're not going to have them. And by the way, I hear that from a lot of companies saying, well, we're just not going to open ourselves up to this risk. We're not going to have all these sensors. Like, fine, go out of business quicker than everybody else. That's good for me. So you do have to address security. My simple answer to your question is security is an extremely complex topic. Do not try and tackle it yourself unless you have a security expert in your company. And you do need a cyber security expert. What I would recommend is that you reach out to your suppliers. Companies like Cisco, where I worked with, they're the world professionals on network security. IBM and others around the hardware security in the data center and so forth. But reach out and leverage their resources. This is a really tricky topic, and I wouldn't try and do it yourselves unless you really do have a security expert. But there are solutions out there. It's a constant game of cat and mouse. We're constantly leapfrogging each other, the good guys and the bad guys. But there are solutions to this. I don't know, hopefully that answered your question to some degree.
Certainly gave guidance.
Yeah, good. Other questions, ladies and gentlemen? Yes, ma'am.
Are you aware of any unsupervised studies done with just narrative data?
Am I aware of any studies done with, unsupervised studies done with just narrative data? And by narrative data you mean?
A narrative of an event.
Written documents, that sort of thing.
Documents,
sure.
correct.
Lots of them. I can't, off the top of my head, site eddy.
Traffic collisions.
Yeah, I can. If you do a search on the web, I'm certain you will find them, and I could do the
So
same.
each area would do something differently, so all of us would write it differently. Like that's not conform standard to where it's finding the exact patterns within that narrative. Because we all write differently, we all have different writing styles.
Yeah, no, this
Even
comes.
though you've gone to training, you're going to have.
Yeah, your text styles will be different.
Correct.
But this comes under the whole heading of text mining and something called natural language processing, which is a whole branch of artificial intelligence and analytics. There's a lot of very sophisticated techniques. So as a sort of example, any of you got an Amazon Echo or geeks hold their hands up. Sorry, didn't mean to insult you. Or the Google Home and so forth. These are the devices that sit in your home and you can talk to them. Well, or Siri, Siri on your phone. And I don't know what the Android version is. They are very sophisticated now. It used to be that natural language processing, you had to train it in advance. You read a script and it learnt your voice and so on. Not anymore. You plug this thing in, turn it on at home, and you can just talk to it. The Amazon one's called Alexa, so I can say, Alexa, I could ask her, what's the weather today? Or I could say, what's the weather going to be like? Or maybe my daughter asked that. So it's not based upon literal text and patterns. It can interpret. So that kind of technology is what's being used to apply to your problem space of taking a whole bunch of texts. And it doesn't matter who wrote and said what. It's not the exact words it's looking for. It can determine those patterns nonetheless. It can even determine things that were not said. This, by the way, is how the FBI and the CIA work. When they're looking for terrorists, oddly enough, terrorists don't tweet and say, by the way, let's put a bomb at this location. So they can't search for the word bomb. I'm being only slightly facetious. They can nonetheless look at those texts and determine that what these two people or more are really talking about is a terrorist threat. So it's very sophisticated now. Text mining, natural language processing, that's the problem. Those are the solutions that work on the problem space you're talking about.
Do you believe that's cost effective for a state?
Absolutely. Depends on the problem. This whole world is not about using technology for technology's sake. It's about what is your business problem? What is the decision you're trying to make? And there is a very good chance that this kind of technology would be cost effective. But I don't know without looking at your problem. If you are using those narratives to make decisions, the chances are you have a fair number of people spending a fair number of hours reading a fair number, or perhaps an unfair number, of narratives to make a decision. That's not cost effective.
That's exactly what we do.
Video analytics.
Mm-hmm.
So case in point, we want to be able to see, or for corrections, so we want to be able to see that the droid has come over the institution and is about ready to drop some contraband. But this video is looking at, 24/7 surveillance, and it needs to be able to trigger when it sees something go across, but interpret it that it's a droid versus a bird.
Mm-hmm.
So we're getting video surveillance in the institution, so major unstructured data coming in. And what kind of analytics are out there for video analytics to be able to do,
Sure.
be able to see that that was a droid versus a bird?
So there are a range of analytics that can do video analytics and determine the difference between a droid or a drone and a bird or whatever else. Goes back to this machine learning example. If I give it a set of videos to say this is a bird, just using this example, it can start to determine the natural movements of birds. They flap their wings and they don't tend, or they do or don't tend to go in straight lines and so forth. Versus a drone which has fixed projections at the end of which are spinning objects. And it could be 6 or 4 or 8 or whatever. And they do tend to, they act differently. That machine learning example, that supervised machine learning example, is the kind that would then look at that and say, okay, I get it. I can tell the difference between a bird which has natural movements and this other thing which doesn't have natural movements. And then it could give you probabilities. This is probably a drone. Now, if it can help you cut down, if you have people, and instead of them having to look at 100 videos, say, just look at these 10, of which those humans determined that 2 of those 10 actually were birds after all. Well, that's still a huge efficiency gain. Now, the other thing I would suggest is talk to your manufacturers. I know, having worked at Cisco for 16 years, Cisco systems, for example, have cameras, security cameras, that perform the analytics inside the camera in real time and can tell the difference between a human being and an animal. So if it's detecting something walking across the parking lot, it can say that's a cat or a dog, that's a human being. Can even tell the difference between a human being that's walking normally and one that's walking furtively and saying, that's suspicious, this person's walking suspiciously. They use this in the medical world to determine a patient that is walking perfectly fine and that one that's in danger of about to have a heart attack. So it can be done. It is being done. Any other questions?
One other question about privacy.
Privacy,
Suppose that you're dealing with customer data and you're doing analytics of it. What responsibility do you have to cleanse that data, or is there any guidance as far as how the data should be treated once you've captured it, especially when it deals with customer data?
Sure, so privacy, customer data, another big, really hairy, difficult problem, but a very important one. And I'll give you my simple guidance at the end. When dealing with customer data, when dealing with personally identifiable information, that's the technical term. First of all, you get into all sorts of complications of what is personally identifiable. Now, if I have your name and address, well, that's pretty identifiable. If I have your social security number, sure. But what if in this room, I don't know how many people we've got in this room, what if I could tell that 5 people fit a certain characteristic? They had certain qualifications or height, or pick a feature. 5 people. Well, if my total population was 1 million people, 5 out of 1 million is pretty personal. 5 out of this room where there's, 25 people, you might say, well, that's not particularly personal. I mean, you could have picked half the room. That's not particularly personal. But if I picked half of the room out of the entire population of the US, that's very personal. So the whole definition of what's personal or not personal is challenging. When dealing with customer data, the general rule of thumb is to remove any of that personally identifiable information if you can, to anonymize the data. But I gave you that first bit because what is anonymous needs some understanding and interpretation. This falls into the whole area of ethics and the ethical use of data and analytics, because as I said a moment ago, I can find things out about conversations between 2 or more people when neither party said any one of those things. But I can tell within a reasonable degree of accuracy that that is exactly what they were talking about. I've built systems for companies where I can tell you, if you press the panic button right now, the fire alarm, whatever, how many people will go out that door versus that door? I can predict that very accurately. I can't predict which one of you will go out which door, but I can do. 1 second, sir, and I'll just finish off his question, I'll be coming right back. My guidance is what I call the red face test. Imagine yourself, on the news at 9 tonight as a company leader. Could you, in all honesty, explain what data you captured, why you captured it, how long you kept it for, what you did with it afterwards, how you protected it? If you can honestly say, we did all of the right things within the best of our ability, but it still got compromised, then the world hopefully will forgive you. But if you can't pass the red face test, companies capture more data than they need for the purpose of use. The second cardinal sin is not to tell people. So even if what you're capturing is perfectly innocent, you need to tell your customers. If they find out from someone else, usually through social media, then it doesn't matter how innocent your intentions were, it doesn't look good. So you have to get out ahead of it and tell your customers, we're capturing this data for these purposes, and we will destroy it after so many weeks or months. And the third guidance would be, wherever possible, give your customers the option to opt in or opt out. Usually that's not the case. I mean, I love these things. You buy a piece of software and it says, do you agree? It's like, no, I just spent $100 on your software just so that you're not going to allow me to use it. Of course I signed, click the little button that says agree. How many of you have ever actually read a EULA agreement?
Excuse me, I do not have Facebook.
You do?
Because I actually went in and read the policies and procedures.
Scary, isn't it?
Yes, it is.
It's very scary.
But we have to read the EULAs.
Oh, you do? It's not fun. Sir, yeah, so hopefully that answers your questions.
I was just wondering about consumer rights. For instance, you download the app to a cartwheel to Target, go to Target, and all of a sudden, bam, your phone starts going off. But all these different things you may have bought in the past. And I was just thinking, what if you're a person that just likes to buy hard liquor and cigarettes, and how do you protect that data from getting to, say, someplace it shouldn't go, so that maybe Target may, would, perhaps sell that information, not you personally, to someone else. And all of a sudden, you're getting insurance because you like it.
Well, the first thing that you should do, unfortunately this is being recorded, but there we are. Pretend it isn't. The first thing you should do is every now and again you screw with the system. So go do a web search for something you have absolutely no interest in. And seriously, because you ever search for something, doesn't matter where you did the search, Google, you look something up on Amazon, wherever it is, 5 seconds later, you go to somewhere like Amazon, and suddenly all of the ads relate to the thing you were searching for 5 minutes ago. So it's capturing all this stuff about you. So as I say, screw with the system. Every now and again, go look for something you have no interest in. Most reputable companies, and back to the red face test, I like to think that most companies are reputable. They try to be reputable. They don't sell data anymore, for the most part, but you need to look into that. If I came across a company that I'm doing business with and I find out they're selling data, I would stop doing business with them in a heartbeat. I'd send their card back, cut it up, do whatever. But most companies are a little bit more responsible than that now. But they'll sell certain elements of it. Again, back to the EULAs, if you actually read through, it's amazing what they do and don't do with your data. Most companies try to be reputable. Actually, Target has a famous story. Have you all heard about the Target story? No? Got a few nods of no, or shakes of no. So I know we've run over. I think it's the last one of the day, so if you want to stick around, we'll just keep going. Well, I'll keep going. He'll tell me if I've got to stop. Target were doing what every other, this is several years ago, were doing what every other company has done in commercial history. They were trying to do targeted marketing. Okay? Analyze your customers to find out who's interested in what, and you send them and only them that marketing material. Has a bigger bang for the buck, and it's all wonderful stuff.
That's the name Target.
That's the name Target, that's right. They took big data, did some analytics to identify what are the characteristics of pregnant women, or expecting women, because they're the ones that are most likely to buy certain products. Your buying patterns change when you're expecting a family, both in terms of clothing and all sorts of other things. So they did that. And that's when the father of an expecting teen discovered that his daughter was pregnant. And of course that hit the news, and Target were accused of spying on their customers, and they weren't. They're a very ethical company. They were doing nothing different than they've been doing for years, using paper, and that every company on the planet does, but it blew up in their face. Now, partly the challenge was they hadn't told their customers what they were doing with that data. They hadn't explained it to them. So now it's really hard to dig your way out of that hole once you've been exposed as having spied on your customers. So it's best to, again, be open, tell people we do capture this data, we look for these things. Second thing I would say is it's going to happen. No matter how careful you are, it will happen. have a media strategy in place. How would you handle this so that when it happens you can react really quickly and hopefully squash it, put the fire out before it starts? I don't actually know of any company that has such a plan. We all wait until it's too late. Any other questions, ladies and gentlemen? Okay, well, thank you for your time. If you have any others, I'll be here for a few moments. Thank you.